So if I have to give a piece of advice to anyone, that will be things will break. Site reliability engineer like us must remain calm and be prepared to act when outage is going on. And that is fun for us. Okay, maybe not that fun. Hi, I'm Leandro Carnero. I am part of the SRE team of iFood. And when I'm not dealing with outages or coding some piece of software to help us to be prepared, I like to drink some beer and walk my dog out.
Hi everyone, I'm João Marques. I'm part of the SR team at iFood too. I love the animes, pets, I have two cats, and containers world. So now I'll talking a little bit of iFood. For those who have never heard about iFood, it's a food delivery app. We are present in Latin America, Brazil, Colombia, and Mexico. And in Brazil, we are the number one. And with the beginning of the quarantine caused by COVID, a thousand of restaurants are relying on a future survive. We are playing an important role here, making our systems reliable to ensure continuity of their business. Okay, talking quickly about of the culture, you code it, you own it. So it means that the software engineers not just code the main functionality of their microservice, but also all the pieces that make the microservice work, such as Terraform code for provisioning infrastructure or Kong YAMLs file to expose the endpoints to the world. There is another good rule at iFood that says give as much autonomy to the software engineers as possible. It means we should create tools to make it easier to push code to the production environment. To be able to give this autonomy, our tools must also have some guardrails to help the engineers on their delivery path. Okay, that is our agenda. We will discuss some topics. Like first, we will start talking about how iFood fits, how Kong fits on iFood at iFood. Then we'll give a tiny overview of the microservice behind Kong. After that, we want to expose how we could increase the resilience of the platform, not touching in the microservice code, just with Kong. We will also talking about what we call safe mode. It's a plan B when things go wrong. And to finish, we will give some look at monitoring Kong.
Okay, so Kong at iFood. Here's a graphical view to be easier to demonstrate how Kong is a thing at iFood. When users are hungry and they want to buy some delicious hamburger, they open the iFood app on their phones and they file a request to our platform. Before the request goes through the platform, they are received to the web application firewall, so WAF, and the CDN, and then it enters to our platform. As you can guess about the icons on the graph, we are using AWS. So Kong, the external load balancer for Kong is our first barrier from those incoming requests. But Kong also can handling the requests that goes from one microservice to other. It's not really a need. We don't need Kong between one microservice to other, but it's really nice to have it. And we're gonna talk about why. So the same cluster of Kong can handle the request north-south requests and east-to-west requests. And we use like two FQDNs in Kong cluster to handle it. So one is for the internal requests, and the other is for the external traffic. So okay, let's talk about some numbers. So here at iFood, we have like 16 productive clusters. Think about 16 control planes. We are using EC2 instances under outscaling group with two load balancers, as mentioned before. A single cluster of Kong can have up to 50 instances and more than 300 houses and some about 100 services and 400 plugins configured on it. So it's really massive for us, of course. All those clusters are handling about to 70,000 requests per second with peaks of more than 100,000 requests per second when people want to buy some dinner. Okay, and to how it works, our EC2 instances have some Prometheus exporters, Filebit to ship the Kong logs directly to Elasticsearch, and also Chef client. So we are using Chef as configuration manager here. Our cookbooks from Chef installs Kong at the latest 2.1 version and some custom plugins. We are using Kong in databaseless mode. It means Chef also clones our Git repository with all the YAML files that Kong needs to work properly. We are not using deck yet. So our Chef cookbook merges all the YAML files into one, interpolates the variables with sensitive information, and posts to Kong slash config endpoint. To ensure all the configurations are correctly loaded to Kong, we create some custom health check endpoint that compares what was declared with what is loaded to Kong. But all this culture of you code it, you want it, all this culture may be a little bit challenging for software engineers to also have to configure the YAML files for Kong. You know, you have a lot of YAML files, so a lot of ways to people have some mistakes or misconfigurations. So think about that. We code two pipelines. The first one is the validation pipeline. It runs every pull request and does some basic validation tasks, such as linting, tag enforcement, check for installed versus declared plugins, or duplicated routes, or any resource names. And we also have some particular conconfigs validation, such as rejects priority. Here at iFood, we use the rejects priority like every slash at the halt, it's a +1 to rejects priority. So if you have like slash orders slash order UUID, it's going to be rejects priority of 2. It's not really necessary to configure it, but we want to be sure how the behaviors will be. So we enforce that. We also have the preserve host enforcement. So that's really a nice one. Sometimes we put Kong in front of S3 buckets. And you know, the S3 buckets with website configured on it, they must to have some host name to route the request to it. So based on some regular expressions we have here, we can apply the regex to the FQDN of the Kong service host and figure it out if the reject priority is false or true. Okay, true is okay, but it must be false when you're talking about some S3 website buckets or some other layer 7 thing or proxy that's handling the request. So based on that, on the rejects, we enforce all the routes for that service to be preserve host false. And after the pull request is approved and all the validations is made, we generate a Git tag. This Git tag, it's used to a deployment pipeline. It's like a canary-ish deployment pipeline. It also have a auto rollback. As you can see in this picture over here, we are using, Jenkins for now, and we have like in a highlight this step of run chef only in one instance, and it means like a canary. We deploy the change to one instance and we check if it's okay. If it's okay, like in the pipeline, we skip the rollback step and go to commit and publish and push all the changes to chef and to all instances in the cluster.
Okay, we have talked a lot about Kong. Let's get a sneak peek how an iFood microservice look like at iFood. So in general, microservices which are not just query processors looks like this image. They are its endpoints mapped to Kong. They are written in a variety of languages such as Go, Rust, Java, and so on. The microservice can publish messages to SNS topics, interact with database, write files to S3 buckets, consume models of SageMakers, and what else. In general, they are regular microservices. Nothing really fancy here. So there's one flow we will talk more about. When a microservice receives a request, let's say a new incoming order was placed, the microservice, after all the validations, will create a new entry in the database. This information can be carried sometime in the future. No news here. As we know, as much as we have some read replicas nodes, a carry to a database can be expensive sometimes. So iFood's microservice, when it's possible, after writing the new incoming order entry to the database, it also writes a file to S3's bucket. Um, we call all the data in the database as hot data. They are a single point of truth. And the data at the asterisk bucket are the called code data. It may be outdated, but they are still there.
Let's talk about how Kong can help us to have some app resilience improved by using secret breakers and fallback. So this is a review how Kong works in a basic way. This is also a picture of our past. So on the left side, we can see a user is requesting a particular order UID. The request goes to Kong, and Kong matches the request with one of its routes. The routes points to the service. Kong does the proxy to orders.food.bars and goes back. And that's awesome. It works. But what if orders.food.bar goes down? So Kong will return some 500 error to the client, and that's not resilient. Okay, so we could, duplicate the orders.foo.bar into orders slash fallback.foo.bar and use the upstreams and targets to split the traffic to 99.9% of the times goes to the order service and the remain traffic goes to the orders fallback. And yeah, that's the idea. That it's right. The idea is right, but we are missing one important part of this concept, the health checks. And at Kong, we have like two types of health checks. We have the active health checks. So think about AWS, Elastic Load Balancers, health check. The active health checks at Kong works really close to that. It keeps probing the service to get the status of the healthiness. So is it alive? Is it alive? Every time it keeps to probing the health check, and it's okay. It's a way to do it. But Kong also have the passive health check, and it's really great stuff. So Kong keeps tracking about the HTTP codes of the microservice is responding to the client. So imagine if Kong receives a lot of 500 errors, Kong marks the target as unhealthy, and that's really nice. It can help us with our task. So let's go back to the picture over there, and yeah. So now we can see. Uh, I think it's the other picture. Okay, now we can see we have the health checks in green over there. We are not exposing all the configurations because they are a little bit bigger to the screen, but they are there and the concept are there. So the concept is there. So Kong now can understand when orders.foo.bar goes down because it receives a lot of 500 errors or some TCP failures and else, and it can shift the traffic to orders slash fallback.foo.bar. So it means what I mean is Kong are handling the traffic and proxying, but orders.foo.bar goes down. And okay, Kong understands it because of the HTTP codes and stops the communication to that servers, that service or that target, right? So after that, Kong will in the shadow, in the behind the scenes, will probe the orders.foo.bar service until it gets healthy again. And when it does, Kongs enables or restores the communication to orders.foo.bar. So the fallback is going to be active 100% of the time when orders.foo.bar is not. So we have app resilience there, and it's really nice, you know? Okay, but we still have some room to improvement. So we have some challenges here. At the passive health checks, Kong also keeps tracks of TCP failures and timeouts. To figure good thresholds to it was a little bit challenging for us and took us a lot of experimentations and load tests to figure it out what is a good threshold to each service or its target. Another thing to keep in mind is at Kong upstreams, the health check part is the same part of the service part. So this is can maybe not true when you're using like actuator from Spring Boot actuator frameworks like that. They may sometimes have another part to get the healthy check endpoint. And another challenge is from this example, we still have like duplicated resource to handle the order service and the order slash fallback services, right? We also, sometimes when we are not using a duplicated service, the path may be not the same, maybe not matches the main app path. So this can be a little bit challenging when using the security breaking in Kong. But for those challenges, we may have some solution. One alternative to the challenges uh, can be using Kong itself as the fallback target. It may be seem a little bit crazy, but let's check it out. So when you're using Kong as the fallback target, we can use like the request transformer plugin or the response transformer plugin or any other plugin to Kong works and response and deal with the request as the same way of the main app does. So we can use Kong as the, the fallback app. So duplicated resources are not needed anymore. So, you know, when we said our microservice, they write data to the database and also to S3 buckets, and we call the hot and the data, hot and the coded data. So we can use Kong to get this code data, and when the main app is not working. So imagine that we can use Kong and request transformer to get this code data, or we can use, I don't know, maybe some AWS Lambda plugin to trigger some Lambda, or get, you know, post the request body when it's a post or a put to some queue, and this queue will be processed later. Anything like that will improve the app resilience. So, okay, here's a picture of what we are using at iFood. So we have the main app, still the orders.food.bar. We still have the get slash orders slash order UUID, but now the target, the fallback target that handles like 0.0.1% of the traffic, uh, it's going to be Kong. You know, it's going to be the localhost colon 8000. Uh, and Kong have this particular route we are calling Kong fallback orders, and is going to use the service as the S3. So when orders.food.bar goes down, Kong handles the request, transforms it, and goes to the S3 bucket and gets the code data. And that's awesome. That's app resilience we would to get without to change the code for the microservices, right? But still things can go wrong. Things can go down, and you know, maybe the outdate uh, data is not enough for us. No, we have to have some plan B, and that is what we call safe mode. So as we mentioned it earlier, we are using this GitOps fashion way of do this stuff. So the changes flows is described in this image over there. So the engineer opens a pull request. The pull request goes through the validation pipeline. It gets validated and gets the reviews, and eventually it gets merged and a Git tag. The Git tag is used to the deploy pipeline that does the canary style of deploying, updates the chef, and roll out all the changes to all Kong instances. But in an outage, it may be a little bit slow process to get these changes to the Kong. Although this is a really good flow, you have changes that are homologated by the pipeline, and you have the reviews. It is easier to roll back because you just need to deploy the latest tag. It is have some documented changes, so you have like uh, auditing because you know whom changed it, when, and we have like this canary we mentioned before, but still a little bit slow process. To have some shortcut, we could use like Kong Manager or a database mode with control plane and data plane. That's a new feature and it's really good. But we would to still have this GitOps way of do the stuffs. So we created a homemade solution to do these shortcuts for us. And that's what it would like. So the safe mode, our plan B, consists of a predefined scenarios, such as enabling rate limiting in halt X, or I don't know, disabling halts in halt Y, you know, something like that. These predefined scenarios, they lived at Git as well, and the SRE team implemented a single page application that renders the status of the scenarios, retrieving all the information from the chef and also from the Git. When a safe mode is enabled, a request goes through the backend of our solution. The backend talks to the chef. The chef triggers a job to update all the Kong instances, and also gets posts a message to a queue that a worker will to consume the message, uh, update Git, and also notifies the users at Slack, so the engineers could run for it and check what's going on. Remember, the single page application, backend and worker were developed by the SRE team. So please do not judge the layout. It's ugly, but it's working. So we have all the switches over there. You can see at Kong Dev Proxy, we have all these predefined safe mode. So imagine here we have just the Discover Legacy 25. It means like 25% of the traffic is going to our platform at this Kong cluster. But we could have like rate limiting at ACL route or something else. You just hit the save button and ta-da, you have the safe mode enabled.
Okay, guys, as good SRE, we should talk about monitoring. Okay, the frequently asked questions about Kong are, how many 500 class errors does Kong cluster are responding? Is the fallback app really working? It is working correctly. To have answers to those questions, we use the Kong Prometheus plugin. Some metrics as well know, such as Kong HTTP status and Kong bandwidth, and they can help us to know if the service is responding and how it is responding. From Kong 2.1 version, Kong Upstream's target healthy was added, helping us to understand how the targets of the upstreams are. And eventually, you can plot graphics like this. In this case, it's showing the traffic by HTTP response codes. In this screenshot, we can see some graphics, requests per second, and HTTP code grouped by code. Or these ones at the bottom, we can see the yellow peaks when the main app is unhealthy, as shown in the upper graph. So, talking about of these two metrics, the metric Kong HPP status can be useful to understand what is the percentage of 500 class errors in a particular route or service. The metric is Kong upstream target healthy. I'm talking about this metric because it was coded by Carnero. No, I'm joking. This metric is exposed the healthy state of an others or target of an upstream. It could be healthy, unhealthy, DNS error. It means once the DNS lookup of the target's FKDN failed. And the last one, health checks off. Once the health checks of the upstreams are not configured. So it means that the host order.full.bar may have two IPs, 10.10.10 or and sorry, 10.10.10.11. A target is marked as unhealthy when all others are marked as unhealthy. Okay. Uh, this is an example of a rule of Prometheus to monitoring the percentage of errors in the target.
Yeah, the Kong upstream target also can help us to alert, for example, when the upstream is added to the production environment, but it's not configured with the health check, so it can alert on it. So it says, oh, the health check is off. So you can see like things like that.
Yes, good, good catch. And okay, this is an example of notification received on Slack. So to Prometheus rule fire, the alert then we receive it in Slack. So it's a simple integration to make visible the alerts. So that's it.
Yeah, that's all we want to show you guys. Thanks for watching. Let's go to the Q&A part.
Thank you guys.